Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. We are excited to be here today to present our topic, classification of metal. This presentation will explore the different types of metal, their unique characteristics, and why understanding them is important in real-world application. But before we begin, let me introduce our group member. My name is Nur Adana Natasha. There's Kaisara Batrisha, Nur Amani Nabila, and Ahmad Amsha. We work together to make this presentation informative and easy to understand. Now, let's dive into the topic.
Metals are among the most essential materials used in both modern industries and everyday life. They are highly valued for their strength, durability, and unique properties, especially electrical and thermal conductivity as well as malleability. Metals can be classified in several ways, but the most common classification are based on composition, magnetic properties, and density. Understanding this classification helps us choose the right type of metal for specific engineering, construction, and manufacturing application. Now, let's look at the main categories of metal. Generally, metals are divided into two broad groups, ferrous metals and non-ferrous metal. Ferrous metal is a content iron and are known for their strength and magnetic properties. Common examples include steel and cast iron. Non-ferrous metal is, on the other hand, do not contain iron and are often resistant to rust and corrosion. For example, include aluminium, copper, and brass. We will explore each of those in more detail in the next slide.
Now, let's begin by looking at ferrous metals, one of the two main types of metal classification. Ferrous metal contain a large proportion of iron Fe. This iron content give them characteristic strength and durability, which makes them highly suitable for structural and industrial application. However, a key challenge is that ferrous metals are prone to rust when exposed to moisture and oxygen if not properly protected. This is due to the oxidation of iron, which is a common issue in construction and outdoor environments. They are also typical magnetic, a property that makes them essential in manufacturing of motors, transformers, and other electrical components. Due to high tensile strength, ferrous metals are commonly used in construction, infrastructure, tools, and transportation industry. What's interesting is that although all ferrous metals contain iron, the property can vary significantly depending on what elements are added and how the metal is processed. Let's take a look at a few examples of ferrous metals to better understand their practical uses. First, mild steel, known for being ductile and strong. It is widely used in frames, pipelines, and general construction. Its ability to be shaped without breaking makes it ideal for fabrication. Second, cast iron. Although brittle, cast iron performs extremely well under compression. This makes it perfect for manhole covers, pipes, and engine blocks where strength is more critical than flexibility. Third, stainless steel. With the addition of chromium, stainless steel becomes resistant to corrosion. It is not only strong but also hygienic, which is why it's used in cutlery, kitchenware, surgical tools, and medical devices. An important takeaway is that the diversity of ferrous metals allow them to meet a wide range of engineering and industrial needs, from heavy-duty structures to high-precision tools.
Now I will be presenting about non-ferrous metals, a key category in the classification of metals. First of all, non-ferrous metals are metals that do not contain iron. This gives them several unique properties compared to ferrous metals. One major advantage is that they are more resistant to corrosion, making them ideal for use in outdoor or harsh environments. They are also lightweight, which is important in industries like aerospace and automotive, where reducing weight can improve performance and efficiency. In addition, non-ferrous metals are usually non-magnetic, which makes them useful in electrical and electronic applications. Another key feature is their high strength-to-weight ratio. This makes them ideal in situations where both durability and lightness are required. So now let me show you a few examples of non-ferrous metals. First is aluminium, which is a non-ferrous metal that is lightweight and resistant to corrosion. It is commonly used in aircraft structures, window frames, and packaging materials. Copper is another example. It has excellent electrical conductivity, which is why it is widely used in electrical wiring and electronic components. Zinc is often used for galvanizing steel. This means it is coated onto steel surfaces to prevent rusting and improve durability. Lastly, lead is a dense metal that also resists corrosion. It is typically used in batteries and in materials that provide protection from radiation. To sum up, non-ferrous metals are very valuable in many industries because of their special properties and wide range of applications.
Now, let's look at the properties of metal. Metal generally have high melting and boiling points, which makes them suitable for high temperature application like engines and industrial machineries. They are also good conductors of heat and electricity, which is why we use metals like copper in wiring and aluminium in coatware. Most metals are dense, giving them strength and durability. They are also malleable and ductile, meaning they can be shaped or strengthened without breaking. This is especially useful in construction and manufacturing. Chemically, metals can oxidize or corrode, especially ferrous metals like iron are less treated or coated. However, some metals like aluminium form a protective oxide layer that prevents further corrosion. Now, why is classifying metals important? Firstly, classification helps us select the right material for the right job. For example, we use ferrous metal like steel in construction for their strength and non-ferrous metal like aluminium in aircraft for their lightweight. Secondly, it aids in cost efficiency. Using the appropriate metal ensure we are not overspending on unnecessary properties. It also contributes to safety and performance. Knowing a metal's strength, corrosion resistance, or conductivity helps avoid failures in building, machines, or electronic systems. Lastly, metal qualification supports sustainability as it helps industries source, recycle, and reuse materials more effectively. In conclusion, metals are essential in nearly every aspect of modern life, from construction and electronics to transportation and manufacturing. Understanding their properties and how they are classified is important for making smart material choices. By choosing the right type of material, we can ensure better performance, safety, and sustainability in the product and structure we create. I think that's all from us. Thank you!